Welcome to How to Hollis. Today we're going to be talking about how to determine compound probability of dependent events. Okay, so this problem says that we've got a purse with 39 American quarters and 23 European coins. And we're going to put all of them in a bag and we're going to pull out two at random. Now you can pull out two at the same time, or you can pull out two one at a time but without replacement. And it has to be without replacement because we know these are dependent events. Dependent means that the probability of the first thing happening changes the probability of the second thing happening. Okay. Now they gave us a little diagram that we can fill in, and it helps us visualize how to do this probability. Whenever you're doing compound probability, the compound probability is the probability of the first event times the probability of the second event. So I'm just going to go ahead and label their diagram. I'm going to say this is event 1. And I'm going to say that this second draw is event 2. So this first little branch in the diagram says we pull out a coin. That coin could be an American quarter or it could be a European coin. So what's the probability of the American quarter? Well, anytime you want to find probability, it is the total number of success divided by the total. So there's, I'm going to go ahead and find the total. Total of all the coins in the little bag are 39 for the quarters plus 23 for the European. 39 plus 23, 3 plus 9 is the 12. Carry the 1, 3, 2, and 6, 62. So the probability of my first draw being a quarter is my 39 quarters divided by my 62 total. Probability of the first draw is a European coin. That's my 23 European coins divided by 62 total. Now here's where it gets a little tricky, but it's not too bad. For event 2, so up here on my diagram, we got a quarter the first draw. Now I want to know what's the probability I get another quarter. Well, now there's not 39 quarters anymore because we just got one. So now there's 38 quarters. And it's not out of 62, it's out of 61. Well, if my first draw was a quarter, the probability of the second one is going to be European. Well, it's all my European coins, which is 23, divided by the number of coins remaining, which is 61. Down here on the second branch, if my first one is European, the second one is quarters. Well, there's 39 quarters still in the bag out of 61 total. And if it's European, well, there's 22 European coins divided by 61. Now, to find my overall probability for multiple events, so this top branch, quarter, quarter, I'm going to write that as parentheses, P parentheses, Q, Q. I'm going to take the top 39 times 38, 39 times 38, that is 1,482. I'm going to divide that by 62 times 61. That is 3,782. My probability of a quarter then a European, again we just multiply the numerators. 39 times 23, that is 897. Now this bottom, 62 times 61, that's going to be the same as the denominators here, 62 times 61. So that is already 3,782. Down on this bottom pathway to go European then quarter, probability of European then quarter, that's the numerator, 23 times 39, 23 times 39. Well, that is 897. 897 divided by 3782, and the probability of European, that's going to be 23 times 22, that is 506 out of 3782. So if I look over here at my original question, the question said, what's the probability of quarter quarter? Well, probability of quarter quarter is 1482 divided by 3782. Now I would go ahead and simplify those, divide out common factors, or I could make it a decimal or a percent. What's the probability of quarter then European? That's this one. That's different from the, now notice it's the same number, but quarter then European, statistically speaking, is different from European than quarter. Unless they specify, it doesn't matter. Over 3, 7, 8, 2. Now probability of no match. Well, quarter, quarter, they matched. European, European, they matched. So probability of no match is these two together. So 897 and 897. Well, that's 897 times 2. That is 1794 divided by 3782. And that is how you find compound probability for dependent events. Thank you and have a great day.